This is part 2 of section 3.5. We just talked about finding vertical asymptotes. Now let's talk about finding a horizontal asymptote. Okay, now if you look back at our general graph right here, our x-axis served as a horizontal asymptote. It controlled our graph. It's basically, you can think of it almost like a magnet. That's how I think of it. It brings it along and it just brings it closer and closer and closer, but you generally never touch it. It is possible to cross a horizontal asymptote. We'll talk about that, okay? It doesn't happen often though. All right, so as our x's go to infinity, the graph gets closer and closer to some sort of horizontal line. Now this looks horrible, but it's actually really easy to deal with. Okay, so generally speaking, when we have a rational function, we have a polynomial over a polynomial. So you should recognize these as just general polynomials. Now, this one is of degree n, this one's of degree m. We don't always, have to have the same one there. So that's why we're using b's here and m's here as opposed to n's up here and a's. So the degree of the numerator is n, the degree of the denominator is m. And basically, we can find our horizontal asymptotes really easily just based on those. Okay? If n is less than m, and I think of this as like having a proper fraction. So if I have 3 over 4, where the degree of the top is less than the degree of the bottom, then the x-axis is a horizontal asymptote every time. If your exponents right here, think of it as making a proper fraction. If they do that, x-axis, horizontal asymptote, you're done. Okay? Now, if they happen to be equal, so if I had a degree of 4 over a degree of 4, then you make a fraction out of your leading coefficients, and that will be your horizontal asymptote. Okay? Now, if the numerator is greater than the denominator, as far as degrees go, we don't have a horizontal asymptote. We might have a slant asymptote. We'll talk about that later. Okay? We never have more than one horizontal asymptote, and a graph can cross it, but the graph is still getting closer and closer. So what tends to happen if you have a horizontal asymptote, if you tend to come in and get close to it. It's possible that you cross it and then get close to it on the other side. And some graphs, you're not going to see this in this class so much, but they tend to oscillate. They go over and go over and over, and they get closer and closer and closer. We don't see that in this class, but it is possible. Okay, so let's get some practice here. Find the horizontal asymptote, if there is one. Okay, so I have 15x over 3x squared plus 1. So we look at our degrees. The degree of the numerator, well, that's an understood exponent of 1, so that's a first degree in the top. 3x squared, that's a degree of 2 in the bottom. The degree of the top is less than the degree of the bottom, so this, you can think of this as making a proper fraction. So that means y equal to 0, which is the x-axis, is our horizontal asymptote. Okay? For this one, the degree of the top is the same as the degree of the bottom, right? 2 and 2. And so what we do when we are looking for our horizontal asymptote here and our degrees are the same, we do y equal to 15 over 13, our leading coefficients, and then reduce that fraction if you can. So that's just 5. So I'm going to have a horizontal asymptote at y equal to 5. Okay, right here, the degree of the top is 3. The degree of the bottom is 2. This is an improper fraction. We have no horizontal asymptote. We may have a slant asymptote. We'll talk about that later. Okay? Now, one thing we do need to know is whether or not we cross these horizontal asymptotes. So how do you know if you cross it? Okay? What we want to do is you set your rational function equal to the number where you have a horizontal asymptote. So I would put 15x over 3x squared plus 1, and I set that equal to 0. okay? Now I solve this. Now I would solve this by multiplying both each sides by this. Since I'm multiplying it by 0, it just goes away. I have 15x equal to 0. Divide by 15, x equals 0. So yes, we do cross this horizontal asymptote, and we cross it at 0 when our x is 0 and our y is 0. Okay, let's try this one. I would take this and set it equal to 5. So I would have 15x squared over 3x squared plus 1 equal to 5. Multiply both sides by this denominator. And it cancels out. So you have 15x squared, distribute here, 15x squared plus 5, and you can start to see that this is not going to work. I would subtract this over here, and I would get 0 equals 5. And this cannot happen, so it never crosses. Okay, so let's talk about actually getting these things graphed. There's a lot of steps here. We've talked through most of them, okay? Sorry. So for graphing this, we want to determine whether or not we have symmetry. So you're plugging in negative x. If you get the same thing back, basically like the equation, the function sort of absorbed all the negatives, then you have x-axis symmetry, which is an even function. It doesn't take long to check these, and they really help out if you happen to have even or odd. Okay? And if you plug in the negative x and it's the negative of the original function, you have odd origin symmetry. Okay? We're going to find the y-intercept, if there is one, by finding f of 0. We're going to find the x-intercepts, if there are any, by plugging it, setting it equal to 0 and solving. We're going to find vertical asymptotes and holes, if we have any. Okay? And so this is basically thinking about your domain. We're going to find our domain, and then we'll determine whether those parts are holes or if they're vertical asymptotes. We're going to find a horizontal asymptote if they are one, and then we're going to determine whether or not we cross. We just did that. We're going to plot at least one point between and beyond each x-intercept and vertical asymptote. Basically, what we've got but before this step is we know our asymptotes, so we know our graph is getting closer to these on one side or some way or the other. We have a couple of points, but we're going to need more points to get a good idea of what's going on. Okay? And then we're going to use all that to get a graph. So let's try this one. Okay? We're going to first decide whether or not we have any kind of symmetry. All right? So we find f of negative x and see what we get. Well, that will give me negative 3x over negative x minus 1. Now, this is definitely not the same as this, so it's not even. So I'm going to take a negative off of this. And when you take a negative off of a fraction, it belongs to the top or the bottom, but not both. This is the same thing as negative 3x over negative x minus 1. And now you look at this and see if it's the same as this, and it's not. Okay? So the answer to part 1 is no symmetry. It cuts your work in half if you have it, but you don't get it that often. It really doesn't take long to check, and it can help a whole lot. Okay? Step 2 is to find the y-intercept, if there is one, by finding f of 0. Well, what is f of 0 here? That would be 3 times 0, which is 0, over 0 minus 1, which is negative 1, so it's 0. So my y-intercept is 0, 0, which is good. All right, now what's step 3? Step 3 is to find the x-intercepts, if there are any, by solving the equation p of x equals 0, which is just right up here. Now, technically, to find an x-intercept, you would set this equal to 0. But then when you did that, you would multiply both sides by q of x, and that's a 0, so it always goes away. So what's happening is we're just sort of cutting out a step here by saying just worry about the numerator. Where the numerator is 0, that's where you have x-intercepts. So our numerator is 3x, set that equal to 0, and you get x equals 0, which means that my only x-intercept also happens to be my y-intercept. Okay? So, part 4. 4 is to find vertical asymptotes, if there are any, and see if there are any holes. Okay? So, we look at this, and we need to check to see if it is in lowest terms, and it is. Nothing cancels out. So, we set our denominator equal to 0, and we get x equals 1. This is a vertical asymptote, because it came from the fraction after it was reduced. There were no zeros that disappeared, quote unquote disappeared, by reducing it, so we don't have any holes here. We never cross a vertical asymptote, so we don't have to check that. Step 5 is to find the horizontal asymptote if there is one, which means we look at our degrees, right? Now, we have the same degree in the top and we have the same degree in the bottom. So that means we take and make a fraction out of the numbers we have up here, our leading coefficient. So we would have a horizontal asymptote at 3 over 1, or just 3. Okay? We need to see if we cross this anywhere, because we could potentially cross a horizontal asymptote. So we take our original and set it equal to 3 and see if we get an answer. I'd multiply both sides by x plus 1, or x minus 1, sorry. And this would cancel out. So I would have, trying to keep enough space here to keep working, I would have 3x equals 3x minus 3, and you can see that this is not going to work. So we never cross it. Okay. All right, now step 6 is to find the extra points, and 7 is actually to do the graph. So what I'm going to do is I'm going to start putting this information on here, and then that will help me figure out where I need to still plug in numbers and figure out what's going on. Okay, so what do I have? I know I don't have symmetry. I know I have this point right here. It is my only it's my y-intercept and my only x-intercept. Okay? I know that, where is it? I have a vertical asymptote at 1. So I'm going to draw in a dotted line here at 1. My graph, as I come into this vertical asymptote from one side or the other, it's either going to shoot up to infinity or it's going to shoot down to negative infinity. One or the other, always. Okay, so now what else do I have? I have a horizontal asymptote at 3. So at 3, I'm going to draw in my asymptote here. And as my graph gets close to this, as my x values go out one direction or other, I'm going to be getting close to this. I also know that I never cross it. Okay, so what else? All we have right now is 1 point, and that's it. So part 6 says to plot at least 1 point between and beyond each x-intercept and vertical asymptote. So what that's saying is I need to plug in some value between here and here, because it's after my x-intercept. I need to plug in a number between here and here, because it's between an x-intercept and a vertical asymptote. And I need to plug in some number over here. Okay? So think of it as 4 separate regions. Here, here, no, 3 separate regions. Just here, between here, and here. So let's find, I don't know, let's do f of negative 2. So what do I get when I plug in negative 2? 3 times negative 2 would be negative 6. Negative 2 minus 1 would be negative 3. So that is 2, right? So f of negative 2, when I plugged in negative 2, I got 2. Okay, so I know that this graph is going to be coming up and getting close right here. And then that means, since I'm not allowed to cross my horizontal asymptote anywhere, this is going to shoot down to here. So I'm going to draw in this part. Okay, now they also ask that we plug in a number between here and here, which means plugging in 0.5. Okay, if you find f of 1/2 or 0.5, what we get is 3 times 0.5 would be 1.5 divided by a negative 0.5. And what would that be? It's negative 3. So at 1/2, I get negative 3, which does force my graph to come down like this. Okay, so that's one side of my graph. I need to find out what happens on this side. Either it's going to be like this, or it's going to be like this. And I just need one more point to figure that out. So let's plug in 2 and see what we get. Let's find f of positive 2. That gives me 3 times 2 is 6 over 2 minus 1 is 1, so this is 6. So when I plugged in 2, I got 6. 1, 2, 3, 4, 5, 6. Okay, now I'm never allowed to cross this axis, this asymptote. I never cross this asymptote, so it's completely stuck right up in here. And I also know that my graph has to go to either positive infinity or negative infinity by a vertical asymptote. It can't go to negative infinity because it would require that we cross this asymptote. So it must come in from up here. And then our graph is going to get close to this horizontal asymptote, but never cross it.